Hello and welcome to C++ Weekly. I'm your host, Jason Turner. In this episode, I want to tell you a fun story about how my Meetup got nerd sniped and the pretty awesome result of what happened. So we had someone at the meetup who basically said that there's no great way to write a currying function in C++. And the requirements went something like this. They wanted it to be kind of like bind, but it only binds the first n parameters of the function. So it's more like bind front. In the case that you pass it some number of parameters, and then it either returns a new function with n parameters bound, or executes the function. So the test case might look something like this. So the first time you call the function, you are getting back a new function. You're saying, I want to curry this add function, and I want the first two parameters, x and y, to be bound to 1 and 2. And then I have a new function, and the next time I call it, I want to pass in 3. And now I expect something like this. I expect that now 6 is going to be returned. And this particular person said that this is a complicated problem to solve in C++. And if you know me, I am a huge fan of lambdas. So I said, hold my beer, I will be right back. And came up with this as a potential solution. In my version, I called it bind, not curry, because I'm thinking about bind first. There's a lot of ellipses to digest here, but we've got this thing that takes a templated callable and a set of templated parameters. That's about what we expected the interface to look like. And we create a new lambda function that takes a copy of that callable and does a variadic capture of the parameters. I believe that was variadic capture added in C++ 20, and generic lambda support, which was C++ 14. Now I have a new function that has the set of parameters that were passed to me and expects another set of parameters, and it returns callable. But I have not actually done anything with this yet. But I do an if const expr, and I am using this technique, which I've covered in previous episodes, that I got from Chris Jusiak, which he got some version of from Andrei Alexandrescu, but this requires C++ 20 concepts and if const expr to work in C++. I say, if the callable thing that was passed to me is callable with the currently known set of parameters, then I simply execute and return that value. If it is not, then I return the new bound thing. And this works. Mostly. So I am binding the first parameter and I am calling it with the second and third parameters, and you can see that I have 6 being returned here from main. I still have my compiler explorer set to ARM mode, so don't worry about it. It's R0 instead of EAX. And if I try to pass too many parameters to it, I'm going to get too many arguments to function, because there's no way to call this thing with 4 parameters. And the original test case, if I swap things around, it looks like this, and that works. And if I pass all 3 parameters to it, then I'm actually getting a value back here, not a new function. So that works. But where mine falls down, that works as well. Where mine falls down is if I wanted to do something like this. I don't have any way of cascading more than once. So then, since, as I stated, the meetup got nerd sniped, Ben Dean actually pulls this version out, which I will paste in. Ben's is very succinct. Now Ben has actually gone to the effort of naming his curry, and it works for this particular use case. We can curry a function with no parameters, then add a parameter and add a parameter and add a parameter and get the execution back, and the compiler has no problem with this, and it returns 6. Ben's relies on recursive instantiation of these variadic templates, and we will attempt to walk through this. We call curry. The first time we call it, we pass it a function object. That is the callable. And we are binding that callable in with 0 additional parameters. This variadic set is 0. And again, we're creating a lambda that can take any number of subsequent parameters. And then it does effectively the same technique that I was looking at. If this thing is callable with the original set of parameters followed by the next set of parameters, then we call it and return its value. If it is not callable in this situation, then we call curry again. And now we already know what the original callable was. Interestingly, this is kind of fascinating. So it doesn't have to keep wrapping the callable over and over again. It repackages it with the set of parameters that have been bound up to this point plus the new set of parameters which were passed in here. So now it is a callable back into this thing with the original function followed by the new set of parameters. So that set of parameters is being copied multiple times, and that could be a problem depending on your specific use case. But this works again, and it works for any set of parameters. It's going to take any callable thing, and it is going to call it if it can. Now, we probably actually want to use standard invoke here so that it's a little bit more generic of a solution, but that's where we have it now. But it was then pointed out that this version doesn't actually work in just kind of the standard case, which mine did work in. If we do this and say we just want to call this function with these 3 parameters, we get, well, a difficult to handle compiler error. That is certain, because it doesn't take into account the case that the very first invocation of this thing could return a result instead of a function. So Ben updated his version, so now it looks like this. And it has a test up front that says if constexpr this thing is callable with these parameters, then simply return the result of calling it with those parameters. Otherwise, jump into the code that we have already dissected, where it knows how to return a new function in the case that it needs to, or it knows how to just invoke the function in the case where it can. And this is good, but we're still not quite there yet. Von Cato, who also comes to my meetup, pointed out that the inner if constexpr is now unneeded. So that's this case right here. We already have a pre-check to see if it's callable with this set of parameters we don't need the post check, if you will. We don't need the inner check because the pre-check caught that scenario. And so the final version becomes something like this, and I'm going to go a little bit against what we got from Clang format. This version is, what is this? 10 lines of code long, and it works in every situation that we can throw at it. And it kind of even works in situations where you don't necessarily expect it to work, like this. If we invoke it with an empty set of parameters, it's, well, going to do exactly what you think it should do. The function is not yet callable with that set of parameters. You passed it no new parameters. It's effectively just going to return itself back to you, which is pretty cool, really. So it made for an awesome meetup, and I hope it made for a fun C++ weekly video, and I plan to put some version of this in that tools repository that I have been sharing with you all, maybe, in the last few episodes and the last couple of months here. I've mentioned it a few times. It's not necessarily exactly perfect because it doesn't handle forwarding. Everything is copied. What do we do in that case? If we take things by reference and only store references to them, then we have a problem with object lifetime and values going out of scope. If we always take copies, then we have a problem with making too many copies. If we parameterize all of this to say, well, if I was passed an R value, then take a copy, otherwise take a reference to it, it gets very complicated quickly. The copy-only version for simple types is, as you can see here, really often going to do what you want it to do. And if you really feel like digging into this, don't forget that you can always click on CVP Insights, and you can walk through this to see what the compiler thinks of all of it, which is an interesting experiment also. Have fun with this. Play with it. Hopefully I'll remember to put some sort of a link to this implementation in the video description, and be sure to attend your local C++ meetup because you really have no idea what's going to happen there.